there we go. So today we are going to be starting the topic of algebra. All right. So I've had a lot of people as we've entered this topic that have had some very real fears and concerns because algebra is a topic of mathematics that y'all have never done before. My message that I want to make sure that we understand, guys, we are doing algebra. There will be letters involved, but we are not going to be doing anything brand new with math, okay? And here's the thing that I also need to understand. If you're worried about like having to add and subtract and multiply letters, you cannot do math with letters. You're going to learn what those letters represent and how to work around them. But I want you to remember, guys, I'm not going to teach you a brand new thing to do with math. If it says A plus B, you can't do anything with that. Do I know how to add an A or a B? No. All right, and you're going to have a problem that might say A plus B. And we're going to talk about how to work with that and what that means, okay? So before we even start, please remember this is 6th grade. This is the very first time you are seeing algebra. We will keep it as simple as possible, but this is the first time you're seeing it. So if you don't feel like I've explained something or you don't understand what I'm saying, please make sure you stop me and let's talk about it, okay? All right, so algebra. It's just math. It's a mathematical language. I'm going to cut off this air because it's real loud in videos. Remind me to turn that back on in the class or it'll get hot in here, okay? A mathematical language of symbols I want to address this real quick. A mathematical language, that sounds fancy. All of math is a language. Every single test that you've had, hasn't there been new vocabulary to learn? Yeah, just like in Spanish, you have new vocabulary to learn, new words to learn. Math really is its own language, okay? So when it says a mathematical language, y'all already been doing that. Y'all are good. Of symbols. And these symbols can be your typical add, subtract, multiply, divide. They're also going to include variables. All right, and that word variables, that's new to us. So the symbols like add, subtract, multiply, divide, we know those. That one's new. But you're also going to have and numbers. We kind of need numbers if we're doing math. All right? In the 6th grade especially, we cannot do math without some numbers. All right? So even though this is algebra, and there are going to be things called variables involved, which are those letters you're thinking of, there's going to be numbers, because that's how we actually do math, okay? All right, so let's talk about that word variable we just underlined. So a variable is a symbol, which we kind of saw in that definition. It is a symbol. As usually in math, we are going to use a letter. All right, and this symbol or this letter is used to represent a number. So that letter, that symbol, really is there because it is a number. Okay. That symbol is a number. So guys, we're going to be doing a lot of algebraic expressions. That's going to be our goal tomorrow. Today, if you look at our learning target, it says I can evaluate a numeric expression. This says algebraic expression. Our learning target today says numeric expression. The only difference is this says algebraic, which means it can have those letters involved, which are variables. Our numeric expression just means, what does the word numeric sound like? Number. So it means numbers. So let's talk about what an algebraic expression is. It's a combination of variables, which are our, what are variables again? They're the letters. They're the letters or symbols. It's a combination of variables, numbers, and operations. Numbers and operations, aren't those just math problems? The only difference is now it can have numbers and operations. It can be a math problem that has variables, that has letters in it. Okay? So today, if we're doing a numeric expression, we're doing a combination of numbers and operations. We'll just leave out the variables. So we're doing some math problems today with numbers. Raise your hand if you've done math problems with numbers before. That should be all of us, yeah? Yeah. Okay? So we're calling them numeric expressions today. You've been doing numeric expressions for a while, haven't you? Now we're just going to make it sound fancy. A numeric expression is just a math problem. Okay? An algebraic expression is just a math problem with some letters involved. A lot of algebra is just fancy words. A lot of algebra is fancy words. So I have a lot of people that come in and they're worried and scared about the letters, when really the vocabulary to me is the hardest thing about algebra, because you're getting new ways of saying things. Okay? So an algebraic expression is just a problem that has your numbers, it has your operations, it also has some letters in it. This is going to be really important. I've seen a lot of y'all, when I give you a math problem, you'll like put an equal sign and you'll write your answer. When we're doing expressions, the way that we write out our math in algebra is going to be important. There are no equal signs in our problem. So guys, you cannot add equal signs to your answer. And we're going to talk about how our answer... Y'all, I spelled that completely wrong. Let me just rewrite that. No equal signs. There are not going to be any equal signs. We'll talk about that more next week. We will see some problems that have equal signs, but they will not be called expressions. Okay? An expression is a math problem. You don't have an equal sign. All right, so I've had some people that are like, well, then how am I going to know where my answer is? Well, it's going to be at the bottom of your work. All of our work when we do algebra will look kind of like a pizza, like a slice of pizza. All right, it'll be in that V shape that a slice of pizza is in, okay? And your answer will always be at the bottom. Got it? Easton? Yes, we will use the please excuse my dear Aunt Sally, the order of operations in algebra. Absolutely. Okay. Let's look at the word evaluate. So this is in our learning target today as well. It says evaluate a numeric expression. So we said a numeric expression is just a math problem with numbers. Evaluate means we want to find the value. We want to find the value, which really means work it out. All right? So on your homework it might say evaluate the numeric expression. That sounds real fancy. All it means is work out the math problem. What this means, guys, is on our test next Friday, if the directions say evaluate the numeric expression and you come up and ask me, hey, what does this mean? That's part of your vocabulary. Okay, that's the big thing that makes algebra challenging, because it sounds like I'm asking you to do something really fancy, but when I say evaluate the numeric expression, it just means work out the math problem. Okay. All right. Now, a lot of times we're not going to be dealing with numeric expressions. We will have these algebra ones with variables. So I want to kind of include that in this definition. So to find the value of an algebraic expression, because can we do math with letters? I already kind of told y'all that. Can we do math with letters? No. To find the value of to evaluate an algebraic, I'm trying to be really careful on my spelling because I'm having some trouble with that today. Expression. You will do this by replacing variables, which are what are variables? Variables are the letters, and we're going to replace them with numbers. I can't do math with letters. I need them to be numbers. Okay, so I'm going to give you an example of an algebraic expression. Okay, put a little star here. Here's an example. I want us to do x plus 5 make sure everyone's caught up. X plus 5. Can I add a letter and a number? No, I already told you we can't do math with a letter, right? So Ms. Sawyer, can't be done. We can't work this problem right now. If that's all I gave you, we need more. Okay, so we're going to work x plus 5 if x equals 3. Okay, so does that mean x is always going to be 3? No. X is 3 for this problem, and only this problem. So if x is 3, part of doing algebra is knowing, hey, that x is going to change to what? A 3. How do I know you changed it to a 3? You write it down. So instead of x, I'm going to write 3 plus 5. And what does 3 plus 5 give me? 8. Did I put any equal signs in there? No, I just worked it going down, and at the bottom was my answer. And you can kind of see this was a really weird small problem, but did it still end up forming like a little bitty pizza slice? Yeah. Okay. There, y'all just did algebra. Now obviously that was a really easy math problem. 3 plus 5. Could I make the math problems harder and longer? Absolutely. It's still just changing the letter to a number, though. Change the letter to a number. How will you know what the number is? I will tell you in the problem, or sometimes you will have to read the directions. That's it? Okay. All right, so let's look at these next two. These next two we're going to talk more about tomorrow, but we're going to go ahead and write them down today. A term is a number. It can also be a variable. So, for example, x would be a term because it's a variable. 5 would be a term because it's a number. Or sometimes, and we'll see this tomorrow and we'll talk about what it means then, sometimes you could have a number with a variable attached to it. All right, in an expression. So basically, guys, terms are the stuff in the math problem. Terms are the stuff in the math problem. So here, these are two terms because they're two things that I am adding. What's important? What's in between them? An addition sign, right? Every single time your terms, your stuff is going to be separated by an addition sign or a minus sign. Okay. So we'll even put in here, terms are separated by operations. Terms are separated by operations. Our next word is like terms. Like terms. What do you think that means? If they're kind of like each other, they are the same. They're the same. So like terms are terms that contain the exact, and that's really important, it has to be the exact same variable. Or variables. It could be plural, so I'm putting an S in parentheses. Okay. So what that means is when I'm looking at numbers and variables, if they have the same letter attached to them, They would be like terms because they're not exactly alike. The numbers can be different. But if the letters are the same, we'll put them together. And again, we're going to talk about that more tomorrow. So if you're not understanding that, I'll give you some examples and we'll look at that more in detail tomorrow, okay? The last thing we need to talk about is the word constant. Remind me, what is a variable? A letter. And what does that letter do? It represents a number. Does it have to represent a specific number every time?
No.
No, so that variable can change. Sometimes x will be 3, like we saw in our problem that we did. Sometimes x will be 95. Sometimes x might be -4. Your variable can change, which means it can vary. Has everyone heard the word vary before? Like where things change, okay? Guys, math people aren't very creative. It's called a variable because it can change. Constant. If something is constant, can it change? No. So guys, what's something in math that can't change? It's always going to represent the same thing. A constant, and that would be called, guys, just a number. When you learned about the number 3 in kindergarten, did the meaning of the number 3 ever change? No. 1, 2, 3. That's how you would find out. If it's the number 3, that means you can count. 1, 2, 3. 3 of whatever it is you're talking about. So a constant, guys, is just a number that's by itself. And the way we'll write that is a term without a variable. Okay, so as you learn more about algebra, this will be more important. But for us, guys, a constant, a term without a variable, is really just a number. If you want to write that underneath, that's what's going to matter. What's in parentheses is a way that we'll kind of talk about it. The definition next to it is what you'll see on the test. Okay. So again, today we're going to talk about numeric expressions. An expression is a math problem. Numeric means it's going to have numbers. Good, because it's math. All right? So we're going to do a numeric expressions. All right? We've actually done these before. We did these earlier in the year. Was everyone okay? Did anyone need that still? Raise your hand if you needed that. Need it? Okay. All right. When we're doing numeric expressions, we are going to use our order of operations, which a lot of us knows is please excuse my dear Aunt Sally. Now that my dear and that Aunt Sally are where people get in trouble. Because you'll notice I didn't write it in a straight line going down. Because if we're talking about my dear Aunt Sally, she's not just my Aunt Sally. Alright? She's not just someone's dear Aunt Sally. She is my dear Aunt Sally. I care a lot about my Aunt Sally. So that ND has to stay together because we're going to do whichever comes first in the problem. Same with the AS, the Aunt Sally. It's not just Sally. It's not just some aunt. Alright, it has to be my Aunt Sally. They're going to have to stay together and go from left to right, okay? And we're going to look at that in this first example. Alright? It's a numeric expression. Y'all seen problems like this all last year, didn't you? Y'all did a lot of these, I think. Practicing order of operations with your brackets and parentheses. Y'all had some really big ones that y'all did. Alright? This one's little compared to what y'all did last year. Alright? It doesn't have any exponents, doesn't have any, it's only got one set of parentheses. This isn't bad, okay? Last year, did you call them numeric expressions? No! Now we're being fancy because we're in the 6th grade. We've got to learn some new words. Now we're going to call it a numeric expression. Is it still a math problem? Yeah. Just now, when you go home, you'll be like, hey, we're learning about numeric expressions. And your parents will be real impressed. And they'll think you're doing something real fancy when really we're just doing math problems. Okay? All right. So let's look at number 1. So according to my please excuse my dear Aunt Sally, what should I do first on number 1? What should I do first on number 1? Brady?
Subtract 7 from 15.
Yeah, so in the parentheses I have 15 minus 7, so I'm going to do that first. 15 minus 7 is? 8. Have I done anything else? So I'm going to write everything else just the way it is. So I have 64 still, divided by still, times 2, minus 9. The rest of the problem stays. You're only doing the part, you're only changing one thing at a time, sorry. You're only going to change one thing at a time. Okay. All right, what am I going to do next? Brayden? Awesome. So it didn't trick Brayden. I really thought I might have had it. All right, I did not manage to trick Brayden. We are going to do this division first. Brayden, can you explain to me why you didn't multiply? Because a lot of us probably thought, hey, M comes first. But remember, is it just my Aunt Sally?
No.
My dear. So which one of those comes first in the problem? The dear. The D, the dividing. Okay? So we're going to do that one first. All right? So 64 divided by 8 is 8 still. So 8 times 2 minus 9. Now what am I going to do? What's going to be my next step? Peyton?
I'm going to multiply 8 times 2.
8 times 2, and that's going to give me?
That's going to give me 16.
16 minus 9. And now 16 minus 9 is going to give me? 7. Okay? And then that's where my answer is, guys. Did I add any equal signs in? No. If the problem doesn't have an equal, you cannot put an equal, okay? But I worked it in that pizza shape. You can see my pizza shape there. And at the bottom we have pizza. You do not have to draw those lines. You do not have to draw those lines. That's just me showing you, hey, there's my slice of pizza that I'm making. All right, pizza?
I did 64, or I did 8 times 2, and I still have...
Okay, so on this problem it did not cause an issue. It will in the future. So I want you to go back and flip those 2 steps around, okay?
Well, I still got some.
On this problem, it did not cause an issue, but it will on future problems. So here, if we did these 2 steps backwards, it's not going to cause an issue because the multiplying and dividing are together. But if they were separately in the problem, it could cause you to get a wrong answer, okay? So I do want you to make sure it has to be dividing, it has to be multiplying. Guys, when we take our test on this next Friday, I will be grading the work. So the way that I'll grade the work is each step is a point. So like here, this will be 1 point, 1 point, 1 point. Your answer is 1 point. So if we mess up the steps, that's 3 points. The right answer is only going to give us 1. Okay? Christian? All right, let's look at number 2. So we're still going to be following the please, excuse, my dear, make sure it's together, left to right, and Aunt Sally, make sure it's together, left to right. All right, what do I need to do first here? What should I do first here? Peyton?
I just said the parentheses, but first you need to multiply 4 times 3.
All right, so we need to do parentheses first, and we do need to take care of this exponent, but that doesn't mean 4 times 3. What does it mean? Okay, so it's 4 to the 3rd power, so Mary Webb, what does that mean to work it out? How would I work it out? Frank? 4 times 4 times 4. The big number tells you what you're multiplying. The little number tells you how many times. All right? So we're going to still leave our 13 stays there plus. Have I done everything in the parentheses? No, so that stays there. So 4 to the 3rd. 4 times 4 is? 16. Now I've got to do 16 times 4, which is 64, divided by 2 times 5 minus 17. What's my next step going to be? Next step, Keegan. We did the 4 to the 3rd. Now we're doing 64 divided by 2 because it's still in the parentheses. So I have 13 plus 64 divided by 2. Anyone got that answer, Peyton? 32 times 5 minus 17. Okay. What's going to be next? What am I going to do in my next step? Mary, what? So now we've done the parentheses, exponent, well, we've done the exponent parentheses. Now we're multiply and divide. So there's multiply. We're going to do 32 times 5. So I get 13 plus 160 minus 17. Thank you to have worked that out. What now? RJ? Remember, it's my Aunt Sally. Which one comes first in the problem? The 13 plus the 160. So we're going to do that first. 13 plus 160. 173 minus 17. And 173 minus 17. Might need to go to the side and work that out because you're going to have to borrow. Easton?
56.
Not quite. Noah?
156.
156. Okay, and that would be my answer. Again, I worked it all the way down to the bottom, making that pizza slice shape. All right, on the next one. An art supply store sells posters for $9 each and picture frames for $15 each. Write an expression. Again, expression just means write a math problem. Write a math problem for the cost of 6 posters and 6 frames. Guys, this is wanting one math problem that's going to give me the answer if I buy 6 posters and 6 frames. Any thoughts or ideas on how I could work that out? Any ideas? Easton?
Do 6 times 9 and 6 times 15.
Okay, close, but I need that to be in one math problem. How would I write that out in one math problem? So she's right, and he's right. I need to do 6 times 9 because I have 6 posters for $9. And I need to do 6 times 15 because I have 6 frames for $15. But I need to write that in one math problem. Peyton?
So we're going to do 6 times 9 in parentheses.
So 6 times 9 in parentheses, okay?
And 6 times 15 right next to the parentheses.
And 6 times 15 in parentheses, okay? Now, if I don't have anything in between, then that means I'm multiplying them afterwards. I need to multiply my posters times my frames. What am I doing with my, if I'm wanting to know the total, if I want to know the total cost, I'm going to have to add those prices up. So I'm doing 6 times 9 because I have 6 posters for $9. It's really important that you have those in the same order. Plus, I'm going to add to that my 6 frames, and how much did they cost? 15. So I did times 15. Okay. Are there any questions on how I set that up? We're going to practice this more on Wednesdays when we'll really start writing them more and practicing. Okay. Then it says, what is the total cost for, pay attention, it says 6 framed posters. So am I just getting 6 posters? No, I'm also getting 6 frames. Guys, that's the problem you just did. We wrote the problem. Now, it sounds like it's asking us something different, but it's really just asking us to work it out. What would I do first to work this out? Right? What did I do first?
Times 9.
6 times 9. So we're going to do that first parentheses. So 6 times 9 gives me 54. Plus, then we still have 6 times 15 in parentheses because we're only doing one thing at a time. Now what am I going to do, Kristen? Multiply 6 times 15. So now I have 54 plus 90. Good job, guys. And now, okay, 54 plus 90. 144. It's a word problem, so I need words. Here, guys, since it asks for the expression, that's just the math problem. You don't have to have words there. But if it asks for the cost of this, we need to tell what the answer is. So the cost of 6 framed posters is $144. You see, I just repeated that instead of saying, what is the cost? I said, the cost is, or the cost of 6 frame posters is $144. Okay, so the homework is on the back. We're going to flip it over and we're going to work some of them together. We're going to work some of them together. All right. I'm going to go ahead over here to the side and remind myself, please excuse my dear Aunt Sally. Remember, these two go left to right. All right. Number 1. What should I do first on number 1? What should I do first on number 1? What do you think, Mason?
Okay. So number 1.
Tempting, because it is Aunt Sally, but remember these are together. So we're going to go from left to right. So which one of these actually comes first in the problem? When I'm talking about adding and subtracting. The subtraction comes first in the problem. Do you see that? So this is one of those trick questions you're going to see a lot on your homework tonight, where we have to do the subtraction first. So 7 minus 6 is going to give me 1 plus 5. And now when I get 1 plus 5, what does that give me? 6. Okay. If I had done it the other way, I would have ended up with 7 minus 11. Can we do 7 minus 11 yet? No. No, it probably means we made a mistake somewhere. Okay. All right, we're going to skip down to number 3. We're going to kind of go down this first row over here. For number 3, what should I do first on number 3? What should I do first on number 3? Braden?
64 minus 8.
64 minus 8, because it comes first in the problem. So 64 minus 8, what does that give me? 56, I think. Plus 21. And then 56 plus 21. Vegan? 56 plus 21?
76. I mean 77.
77. All right, let's look at number 5. Number 5, what am I going to do first here? Right.
89 minus 67.
Yeah. If these parentheses weren't here, we would have had to do the adding. Those parentheses are really important here since it was listed second. Okay, so I still have 28 plus, what is 89 minus 67 going to give me? Issa? 22. And then when we add that together, we get? Jessica? 50. Okay. Move it on down. Write it again since it's not on my screen anymore. Number 7, what should I do first? RJ.
63. Wait. No, 8.
All right, so please excuse my dear, which is my multiplying and dividing, is on top of the adding and subtracting. So you had it right the first time. The 63 divided by 9 was correct. Okay, 63 divided by 9 gives me 7 plus 8. And then for my answer, I get
15.
Number 9. Order of operations. What am I going to do first? What are we doing first here? Kelsey. Okay. Which one? So it says MD, multiply and divide. Which one comes first in the problem? The multiplication. I think I've made you so nervous about going in order, y'all are wanting to do it backwards. All right? You just do these in order. So guys, when we're putting that ND with the arrow and the AS with the arrow, you're just doing it in the order of the problem. That's what that arrow means. All right, so 13 times 4 is Carrie? 52 minus 72 divided by 8. Okay, now what should I do? Now what should we do, Gabriella? All right, can't subtract. We still haven't done all the stuff on top. So you are correct. We're going to do the 72 divided by 8. If all else fails, look at your list here, okay? That's why we have it there. So parentheses aren't there, exponent aren't there, but multiplying and dividing, we're still working on those. So I end up with 52 minus 9. Now, all that's left is 52 minus 9, which gives me 43. Okay. Number 11, 12, and 13. Number 11, what am I going to do first, Shalia? On number 11? Oh, you said minus 6. Yes, sorry. I don't know where I got 96 from, but minus 6 is correct. So we're going to do our 21 minus 6. So I get 30 divided by 21 minus 6 is 15 times 4. All right. Now this time, what am I going to do next? What do you think, Haley? Very good. So this is when I would do my division first because they are in the same list. And which one came first in the problem? The division. Do y'all see how we chose that? And 30 divided by 15 is? 2, I hope. And then my answer is going to be what here? Gabby? Thank you. Speak up. I'll usually be much better at participation. All right. Number 13, being careful with my list over here. What should I do first on number 13? Brayden. So that's subtraction. Subtraction's all the way down here at the bottom. Is there any parentheses, exponent, or multiplying or dividing that I could do? What can I do? Parentheses, exponent, multiply, divide, and then we would add and subtract last.
16 times 5.
The 16 times 5. All right, looks big, but we do need to do that first because multiplying comes before adding and subtracting. So I have 88 minus 16 times 5. 50. I think it's 80. I think it's 80. Right. All right, then plus 2 minus 3. Now what? Now what should I do? What do you think, Keegan? Perfect. Now all of this is adding and subtracting, so we're just going to go from the left of the problem to the right. So 88 minus 80 is? 8 plus 2 minus 3. Now what am I going to do? Mary Webb? We're going to add 8 plus 2. Guys, we're not just going through and doing subtracting. We're just doing it from whatever's first to whatever's last. So 8 plus 2 is? 10 minus 3. And 10 minus 3? 7. All right, number 15. Order of operation. What should I do first on 15? What are we going to do first here? Peyton.
4 times the third power.
All right, so 4 to the third power means 4 times 4 times 4, which we already worked out on the front. What was that? 64 minus 24 divided by 8. What's my next step going to be here, Gabby? We're going to divide. 24 divided by 8. So I get 64 minus 3. I had to think about that for a second. I was thinking 4. I was wrong. Okay, so 24 divided by 8 is 3. And now we have 64 minus 3, which is 61. Okay. So guys, that really only leaves that second side of your homework to work on. Okay. So please make sure you're working on that.